Welcome back to the lab. This is lab of class 12. So we have just gone through mediation analyses, and now we're continuing our journey by basically looking at the Matty-Fox analysis here, which is shown here towards data science link. So you just have to click on the PDF and you can follow this. So exactly this tutorial. I will just quickly walk you through the code, and then you can work on the lab. Okay, so this is the full analysis. This is the full class. We will now be opening. I'm not even sharing my screen yet. Okay, so the screen. Okay, so we are seeing now, okay, so in the lab folder, you have now here the RMD file. The RMD file essentially allows for you to, this was in May when Marcel and Bino did this. We are doing now, this is 11, now that's 19, but it's for 22. We're knitting this. You can look into the additional file. So once again, I think I hope in the meanwhile you know now how to knit things. So essentially, when you are okay, so let's clear this environment. I played around with it already before. So you include library mediation. Once this is loaded, essentially you can see here, and this is the analysis that was shown in class, right? So we have looked at this in class. So this is emotions. You have the same code also in the class file, in the class RMD. So you can now essentially run the same models as the RMD file showed. So essentially you have treatment, yes, no. So this with the mediation being affected by the treatment of getting an shocking or anxiety-provoking news article is an effect of 1.33, right? So if we're now fitting the outcome, taking into account the emo, so this is the total effect, right? We're getting here now 1. Oh, summary outcome. This was the wrong one. You have your summary outcome fit. You're basically getting here. An effect of, and this was the question we had before, right? Fit coefficient. No, that's not this one. LS outstat fit. Here we get our coefficients. This is exp outs.fit coefficients. There's an additional parenthesis. Okay, so treatment has a 7%, has a 7.7 effect. Well, the treatment effect increasing the odds of the individual wanting to contact Congress by 7.7%. So if we are looking at this now in our mediation, so this is mediate, we talked about this, right? Net fit is the fit of the mediator. Outfit is the outcome fit, the binomial, family binomial, which is logistic regression. Treat equals treatment, mediator is emo. We're looking now at emo, emotions, to essentially mediate the effect from exposure to outcome or treatment to outcome. We're doing the bootstrapping, which is true, and we simulate by 1,000. These are the bootstrapping simulations. So this is, Python is still running. Okay, for you, for those of you who are a little bit more technically inclined, so you can run two things in R, which is usually a little tricky. So I was not particularly smart with it because R is now kind of acting out. So the reason for that is it's a 64-bit operating system, and since it's Mac by default, R runs on a 64-bit version. 64-bit means that they can basically handle several instances of one application on a respective dedicated core of the CPU, meaning that I hypothetically, and I would be much smarter to do, that I essentially, I'm basically causing R to now getting in real troubles. We're gonna do this on this one we let run, and we leave that unchanged. So hypothetically, I could open a second instance of R, and I have done that on the various for projects. So depending on the number of cores you have, and I don't know how tech savvy you are. For those of you tech savvy, each CPU has different cores. Now, the core is basically the part of the CPU that does one computation. It does many computations, one after another, but basically it's one core. And 64-bit versions can use and allocate different instances on different cores. It works in the cores in a more parallel fashion, and can, in addition to that, use several instances, allocate them to different cores. What is still a problem at this point is that you need to route your R working files to different environments. Because what happened here, for example, the whole thing totally gave up on me. And that could be because I had two processes at the same time. Okay, so I will pause the recording. We're gonna do this quick. Okay. For the sake of being able to show you quickly what we're doing here, I'm gonna reduce the simulation time. You and your computers, you can do the 1,000. Okay, so library mediation. We have here the mediation fit, the summary fit. This is our pathway from the exposure to the mediator. This is our outcome fit. This is our total effect, right? And essentially now we can distinguish between the mediated effect And I've reduced here the number of simulations to 10. I'm putting them back right now to 1,000. And you can do here the same simulations that you have seen with in the lecture can be seen here. We see the same total effect. We see a comparable magnitude. We see the average causal mediated effect, and we see the average direct effect. So now for the Irish example, we are supposed to do the following. So we are getting now a DF down, which is the Irish example. So if we look at the Irish example, to head DF, we see here we have septal length, septal width, petal length, petal width, and species. So now we are looking at, we're creating a randomly generated variable that essentially starts with a minimum of septal length and a maximum of septal length. So this essentially is giving us a random variable with a minimum defined by septal length. So now we are creating a mediator based on septal length and this random septal length confounding effect. So DF mediator is now showing us the mediator as estimated, right? So now we are creating a second variable, which is now min and max mediator, which is essentially now allowing for us to weighing it, just like being asked by the lab. We are being asked, we are giving now mediator attractiveness, a simulated 35% contribution by septal length and 65% random noise. So we are having now septal length at 0.35 weight. So we're creating a mediator simulated with septal length multiplied by 30.5 and a random variable septal length and 65% random noise. The outcome Y, likelihood to be pollinated by a bee, is simulated similarly. And this is now defined by this line. So we have DF random 2 is now this random, hold on. Okay, let's do this again. That's my flow. Okay, so we have random 1. Random 1 is our random noise. Mediator is now put together 35% its value and 65% of random noise. So this is our mediator. In our example, random noise could be plant, non-plant specific attributes like the location of the flower, weather conditions, soil, etc. So now we're creating a dependent variable, which is now our outcome, right? So now if we do heads DV or heads DF, we are getting now random 1, the mediator, random 2, the dependent variable. And we're getting now a fit of a total effect, this dependent variable as a function of sepal length. I don't know much about botanics, but we get here an estimate for sepal length. So now we're doing the same with mediator. We're predicting the mediator now. We're getting a mediator fit where we see that length predicts mediator. Fit of the dependent variable is now sepal length mediator. And this is basically defined by this workout. And we can go now, we can look for this tutorial. And here we see exactly this creation of noise. Flower, weather conditions, soil. So now with the mediation packages, and again, I have reduced this now to 10. What we're getting here now, our ACME, ADE total effect, and our proportion of what is being mediated, which is 87% is mediated of that total effect. So what does this mean? What does this all mean? This means that we have a direct effect, which is marginal, non-significant, because all is being mediated by soil, soil quality, weather condition, location, etc., etc. And so now for the lab, you are being asked to rerun the mediation analysis using this mediator model and the outcome model. So you're using these models. And then you're being asked to use the correct model where you're actually adding the confounder based on the data. So then compare these results and upload this to Blackboard. Now, I think this should be fairly simple at this point in time. And I think there shouldn't be any problems. So you essentially, you just use the real model that is being asked from you. All right, make sure to change this back to 1000 simulation. And then you can rerun the whole thing. All right, good luck on that. Let me know if any questions, post to the discussion board if any questions, and I'll be in touch next week. And well, let's have a good interactive chat about it. If there are any questions, if you want to know more about mediation, happy to hop on a call and schedule something with you. As for the rest, well, please review homework research note 2. Get started on that. Homework is due on 12/02 because I've posted a little late, so you have a little bit more wiggle room and you have the whole long weekend. And as for the rest, happy Thanksgiving. Enjoy your long weekend. Enjoy spending time with your family, and we will talk soon. Bye-bye.